So, good evening everyone. I am Pushpita. I am a PMRF scholar and I am doing my PhD at IIT Delhi under UGADA department in the topic of terahertz, spectroscopy and imaging. I am TA for your today's class. So, the first question for today's topic is d square y plus dt square plus y is equal to f of t. Here y is equal to y at x is equal here t, y at t is equal to 0 is 0 and y dash at t is equal to 0 is also 0. Suppose function of t is 1 between 0 to 4 and 0 greater than 4. So we need to solve that differential equation using Green's method. So Green function method to compute the value of the function at time t is equal to 10 mark the correct answer. Okay, so let us begin. So the equation is d square y dt square plus y is equal to f of t. Okay, so Green's function need to follow that equation, so we can write gt t dash dt square plus gt t dash is equal to delta t dash t, or we can write delta t dash minus t. So for solution we need to take the Laplace transformation. So that would be it was given the condition that y at 0 is equal to 0 and y dash 0 is equal to 0. So we can say 0 is 0 and g dash 0 is equal to also 0. For that reason, Laplace transformation of g t square is only s square g minus s g at 0, which is also 0, minus dg0 dt, which is 0. So it only s square g, and Laplace transformation of gt t dash is equal to gs. And Laplace transformation of delta t dash t is equal to e to the power minus s t dash. So putting all these value into the equation, we get s square gs plus gs is equal to e to the power minus s t dash. So here we can see gs is e to the power minus st by 1 plus s square. Now we need to take inverse Laplace transformation. We know there is a two function e to the power minus st dash and 1 by 1 plus s square. This 1 by 1 plus s square part will give us sine function, and because of e to the power minus st dash, the sine function will be shifted from t to t dash. So we can write as 0 minus sine t minus t dash when t is greater than t dash, but if t is less than t dash, the function will be 0. So the actual solution is y of t is equal to 0 to infinity t dash f of t dash dt. So we know f of t dash is equal to 1 for t between 1 to 4. So t dash is sine t minus t dash to 1 dt at y is 10, that's mean t is equal to 10, it will be 0 to infinity sine 10 minus t dash dt. So answer is that it will be 0 to 4. This is also the Green's function. So the Green's function satisfy this equation t square plus omega square g t dash is equal to f of t. So here we need to take Laplace transformation. So Laplace transformation is t dash dt square function of t. Okay. So it will be delta t dash, and that is also delta. Okay, sorry, it is not. T dash t and it is also t dash t. So we need to consider here also for our simplicity y at t is equal to 0 is 0, y dash t is equal to 0. So Laplace transformation of g is Laplace transform means g dash 0. All these things are 0, so it only s square g. So the and Laplace transformation of delta t dash t is equal to e to the power minus s t dash. So if we put this value, we plug in this value in the equation, we get it is also s and it is also s is equal to e to the power minus s t dash. So g is will become e to the power minus s t dash s square plus omega square. So we can say that now we need to take inverse Laplace transformation. So g t dash will be for this part that will be shifted to t dash, and there will be a omega also, so that will be sine omega t minus t dash when t is greater than t dash, otherwise it is 0 when t is less than t dash. So the solution is y of t is equal to 0 to infinity f of t dash g t dash dt. So it will be 0 to t sine of omega t minus t dash into 1 dt dash. So now we need to integrate it. When it is 1, f of x is 1, or we can say f of okay, this is f of x is 1 when it is less than a, or otherwise it is 0. So upon integration we will get that y of t is equal to 1 by omega square cos omega t minus a minus cos of omega t when t is greater than a, and 1 by omega square 1 minus cos of omega t when t is less than a. This part will become 0. So the answer is equation A and C. Now we need to do this differential equation. If t is assumed to be d square y dt square minus a square y is equal to f of t. So you know again that and those conditions are the same. So we need to take Laplace transformation of this. So L d square y dt square hold a minute. It is y by t, here it is 1 by omega Now you will get this kind of solution when you like the condition here is function of t. T is 1 when it is between 0 to a and otherwise it is 0. So you can assume that f of t dash is actually sine omega t in the region 0 to 2a. Then you will get this kind of solution. So if you assume that it is sine omega t, then only you will get this solution. Otherwise it is up to that. Let's go back to this problem, that is d square gt t dash dt square. It only happen a square gs and L delta t dash t is equal to e to the power minus s t dash. So plugging in all this thing in the actual equation, we get s square gs minus s square. Gs is equal to e to the power minus s t dash. So gs is equal to e to the power minus st dash s square minus s square minus s square. So after doing inverse Laplace transformation, it is t dash is equal to 1 by a sine h. It will be a hyperbolic function minus t dash there will be a 1 by omega. T dash when t is greater than t dash, otherwise it is 0. So it will be a hyperbolic function, which is this. Question number D. Now we need to again apply those things. Here it is d square y dt square is equal to minus is equal to e to the power minus t. So Laplace transformation, t and this values are boundary conditions are same, so d square y dt square minus y Laplace transformation of del t minus t dash. Again it only gives this part as g0 equal to 0 and g dash 0 is also 0. L of y is gs. So it will become s square gs minus gs is equal to e to the power minus st dash. So gs will be e to the power minus st dash s square minus 1. So this will give us an hyperbolic function, which is 0 and sine hyperbolic t minus t dash. It is t less than t dash, it is t greater than t dash. So now we need to compute yt, which is 0 to infinity, or we can say 0 to t, big g t dash function of t dash dt dash. So 0 to t sine of h t dash t minus t dash actually. F of t dash is equal to e to the power minus t dash d t dash. So this is half 0 to t e to the power t minus t dash minus e to the power minus t dash t dash. e to the power minus t dash dt dash 0 to t e to the power t minus 2t dash minus e to the power minus t dt dash. So half of 0 to t e to the power t minus 2t dash dt dash minus half of e to the power minus t outside of integration, because integration is on t dash, here nothing is t dash term. So this term will be half of sine h t, and this term will be half of e to the power minus t into t. Sine hyperbolic t is e to the power t minus e to the power minus t by 2 minus half of e to the power minus t into t. So after simplification it will be 1 by 4 e to the power t minus 1 by 4, 1 plus 2t e to the power minus t. So at t is equal to 1, y t is 1 by 4 e minus 1 by 4, 1 plus 2 which is 3 into 1 by e. So e by 4 minus 3 by 4, 1 by e is your answer. Now question number 5. Consider the differential equation. Sorry for the network issue. Due to the network issue, the video went wrong. Consider the differential equation d2y dx square plus x square minus 4 dy by dx plus x cube y is equal to 0. So we need to know what the ordinary points are. So what is the definition of actually ordinary points? To know that the definition of ordinary points, we need to write the equation in a certain way. So okay, let us write the equation in an ordinary way. The function, it is the normalized y. This is the normalized version. There are two type of point, ordinary point and singular point. So sorry. Ordinary point where the px and qx remain finite at x is equal to x naught, then they are ordinary point. But there is also a singular point where px and qx both are infinite, when it at x is equal to x naught. But after this there are two kind of singular point. One is regular singular point, and another is irregular singular point. So what is regular singular point? Regular singular point keep px and qx diverges at x is equal to x naught, but px into x minus x naught and qx into x minus x naught square remain finite. Irregular singular point is what? That is x naught px, or hello Payal, I am solving the assignment problems. After that I will solve your problem. Okay? Yeah? What did you say?
Okay, ma'am.
Okay. And x minus x naught whole square, not and, or, it is not and, it is or, that any of this if diverges at x minus x naught, then it is irregular singular point. You don't need to both of them to diverge. So by seeing this, can say what is here px and qx. Here px is x square minus 4 and qx is x cube y. X square minus 4, qx is x cube. Okay, that is plus, okay, this is plus and then plus x is cube. So at x is equal to x naught is equal to plus minus 2, px does not diverge. It becomes 0 but doesn't diverge. Diverge means this became infinity. Okay, and so at plus minus 2 it is 8, that is not divergence at all. So here all points are ordinary points are here, because at no point this px and qx will diverge. So the option B, all points are ordinary points for this differential equation. And we can find two independent power series expansion about any point that are solution of the differential equation. Yes, it is also true, because at x is equal to plus minus 2, you can like have power series solution and another point also. So okay, question number 6 also is that, but first it has to be written in the form of d square y dx square plus px dy dx plus qx y is equal to 0. So it can be, the equation is plus x square minus 4 dy dx plus x by x plus 2y is equal to 0. So if we need to write it in the form like that, we need to divide both sides of the equation by x. So here px is 1 x square minus 4 by x and qx is 1 by x plus 2. So from here we know at x is equal to 0 px will diverge, and at x is equal to minus 2 qx will diverge. So the point x is equal to minus 2 is a singular point, okay, and the point x is a singular point. Yes, these two are correct. A singular point, after that if they ask it if it is a regular singular point or irregular singular point, then your concern comes. Otherwise it is enough to obtain the singularity. Find the power series solution. Okay, so for power series solution, we need to assume this is Cn x to the power n. So dy by dx will be, all the n are 0 to infinity. Okay, please keep it in mind. Cn n x to the power n minus 1, and d square y dx square will be Cn n into n minus 1 x to the power n minus 2. So the equations are d square y dx square plus x dy dx plus x square plus 2y is equal to 0. We need to plug in this, plug in the value of d2y dx2 dy dx all. After putting all of this, it will become Cn n minus 1 x to the power n minus 2 plus x n is equal to from 0 to infinity Cn n x to the power n minus y n minus 1 plus x square plus 2 Cn x to the power n is equal to 0. And we need to write it. It is n into n minus 1 x to the power n minus 2. This will become Cn x, sorry, it is not n, it will be x to the power n plus Cn coefficient according to their values into n minus 1 x to the power n minus 2 Cn n x to the power n plus, here it is 2cn x to the power n plus cn xn plus 2 is equal to 0. Now here it is n minus 2, so n minus, if we replace n minus 2 by n, and here it is n plus 2, so it is replaced by n. It is being done because to make all the power of x as x to the power n, and we get a recurrence relation also. So it will become cn plus 2 n plus 2 into n plus 1 x to the power n plus cn n plus 2 x to the power n plus cn minus 2 x to the power n is equal to 0.
मैम आपकी लाइन का आंसर है मैम आगे लाइन का आंसर मैसेज हो रहा है
Okay, we replace in the, here we replace n minus 2 by n, and here we replace n plus 2 by n. Okay, because to make all the power of x is equal to x to the power n, such that we have a recurrence relation, because here all the coefficient are c to the power cn, we will not get any recurrence relation. We need a recurrence relation. Recurrence relation is what? We need a relation that if we know c0, we can know c1 or c2. To solve the equation, we need a recurrence relation, like cn plus 2 is something into cn, or cn is equal to something into cn minus 2. But here all the coefficient are cn, we will not get any recurrence relation. Even if there was a term like x to the power n minus 2 in the coefficient, there would be cn and cn plus 2. Then also equating the coefficient of x to the power n minus 2 at left hand side and right hand side, we could have get some recurrence relation. But here we can see, if we equate the coefficient of x to the power n minus 2 or x to the power n or x to the power n plus 2 at left hand side of the equation or right hand side of the equation, we will not get any recurrence relation. We need a recurrence relation. That's why we need to replace n minus 2 by n and also n plus 2 by n. Am I able to explain to you?
Yes.
Okay, good. So the equation becomes like this: n plus 2 into n plus 1 cn plus 2 into x to the power n plus cn n x to the power n plus cn minus 2x to the power n plus 2 cn x to the power n is equal to 0. Now these equations are here n start from 2 to infinity. Here it start from n is equal to 1 to infinity. It is 0 to infinity. It is also 2 to infinity. So if we add something to the equation, so these are all the like coefficient of x to the power n. So when we compute the coefficient of x to the power n in the left hand side, equate left hand side and right hand side, we get what? N is equal to 2 to infinity n plus 2 n plus 1 c n plus 2 plus is equal to 1 to infinity c n into n plus is equal to 2 to infinity c n minus 2 plus 2 0 to infinity c n is equal to 0. Now if we put n is equal to 0, or like 1, if we put n is equal to 0, so c0, and there will be 2 or 3 c2 plus, no, here n start from 2. Let us first write the recurrence relation at once, where it will be cn plus 2n plus 1 into n plus 2 plus n plus 2 c to the power n plus cn minus 2 to the power n. It is like that. So here we need to consider one thing also, like when we make n minus 2 to n, this limit was n is equal to 0 to infinity. When we make n minus 2 to n, this limit becomes, n is equal to 2 to infinity. Okay, not here, we have made those. Okay, here it is simple. Here when we make like, okay, here we have already, this is that, here we need to make that. Okay, here when we replace n minus 2 by n, then n becomes, when n is equal to 0 to infinity, so n minus 2 becomes 0 to infinity. N minus 2 is replaced by n, so n minus 2 is equal to 0 means n is equal to 2. So this limit become this, and this is also become 2 to infinity, because n, if we put 0, so it will become c0 minus 2 c minus 2, which is not a feasible solution. So here also we need to, okay, convey like this. So recurrence relation will be something like this. It is 2 minus n plus 2 c to the power n plus Cn minus, it is 0. So now if we equate the coefficient of x to the power n is left hand side and right hand side. So right hand side is 0, so this thing should be equal to 0. So from that we get a coefficient recurrence relation, which is this. Okay, and from here it is n is equal to 2 to infinity, it is 1 to infinity, it is 2 to infinity, and again it is 0 to infinity. So to make all those things at equal from n is equal to 2, what you can write, it is 2c0 plus 2c1 plus 2c2 and all that. So 2 into n is equal to 0 to infinity Cn can be written as 2 into c0 plus c1 plus n is equal to 2 to infinity 2 into Cn. Okay, again this part also can be written like it is n is equal to 1 to infinity. So this start with
বলছি কোনো একটা পাওয়ার n to the power x to the power n plus 2 ছিল, সেটার ক্ষেত্রে তো n equals to -2 থেকে ইনফিনিটি হওয়ার কথা।
But I already said if c minus 1, c minus 2 doesn't make sense any. Okay, or because we don't consider those things. We always consider from c is equal to 0. So whenever you put the value here n minus 2 needs to be 0. The lowest, the coefficient c naught, it has to be, because when we solve this kind of problem, the basic assumption first we have also taken in the theory of this kind of calculation, that the lowest coefficient x can have is c naught, not less than that. Okay. Okay. Okay, this is n. So this become okay, n is equal to 2 to infinity Cn into n plus 1 Cn. Okay, and it is also so this part needs to be the limit of here we have put that also Cn x to the power n minus 1, where it was n to the power minus 1, then here it is n plus 2, so it became okay. The lowest is here should be c naught, so it is justified, it is n is equal to 2 to infinity. Okay, and here also the part is there where it is 1 to infinity, but it should be 0 to infinity, because it should not start from like 0 4 C4, it also start from C0. So it is 0. So when it is 0, this part also gives, like 0 part is 3 into C2 plus when 1 is n is equal to 1, when it is 1 3, okay, it is 2, first it is 2 into C2 with 3 into 2 6 into C3 plus n is equal to 2 to infinity n plus 2 into n plus 1 Cn plus 2. So all this thing will be here in addition term, 2 C0 plus C2 plus 3 into C1 plus 2 C3 plus this thing. So it will be equal to 0, and this part also, which is the extra part, this will be also equal to 0. So we can say C0 plus C2 is equal to 0 and C1 plus 2 C3 is equal to 0. So from that it is conveyed that C3 is equal to minus C1 by 2 and C2 is equal to minus C0. So now we have a recurrence relation, which is this, and relation between them also, that C2 is equal to minus C0 and C3 is equal to minus C1 2. So in the recurrence relation you can observe that it is a step of 2, n minus 2 to Cn and also n plus 2. So if we put n is equal to 2, we get C0, here C2, here C4. Okay, so it is a step of 2. So we need C0 and also C1. So we get C2 is what is C0, and we need to write all whole solution in terms of C0 and C1. So C3 is equal to minus C1 2. Recurrence relation is Cn plus 2 is equal to minus n plus 2 Cn plus Cn minus 2, which is minus whole, and n plus 1 into n plus 2. We can write C0 as a C0, C1 as a C1. Then C2 we have already accomplished, it is C0. C3 is equal to minus C1 by 2, and we need to find C4. C4 means n is equal to 2. So what it will become? N is equal to 2, it is 3 into 4 minus 2 plus 2 4 Cn, n is equal to 2 plus 2 minus 2, n is equal to 2, it is C0. C2 is what? Minus C0. So here it is minus 4 C0 plus C0. So it will be minus 3 C0 also a minus. Let me write in the next page. C4 is equal to minus 4C0 plus C0, 3 into 4. So it will be minus into minus 3C0, 3 into 4. So it will be C0 4. Next C5. For C5 it will be 3 in the recurrence relation, and it will be 3. So 3 plus 2 C1. Okay, C5 it will be C3 plus C1, then 4 into 5. So minus here 5 C3 plus C1, 4 into 5. C3 is also minus C1 by 2. So minus here 5 into minus C1 by 2 plus C1, 4 cross 5. After simplification it will become 3C1, 40. So why we have assumed Cn x to the power n. So Jyoti is Payal, it is also from here we assume that n should not be a negative value, because then it will have, if there is a C minus n like C minus 1, so there will be x to the power minus 1. We are not assuming that x to the power minus 1 is there in the power series solution. That is why also there is a boundary, the coefficient should not go into negative. So it is C0 but C1x plus C2x2 plus C3x cube plus C4x to the power 4 and all that. So C0 minus C0 x square, because C2 is equal to minus C0, plus C0 by 4 x to the power 4, plus here C1x, C3 is minus C1 by 2 x cube, C4 is C1 by 3 into C1 by 40 x to the power 5. Let us calculate what it will be. Minus 5 by 1 minus 5 by 2 minus 2 minus 5 minus 3 by 5, which is, so 3 by 5 C1 into 4 into 5, which is, it should be 100. Okay, it is 2. Just right. So answer is C1. This is the answer. Now find the power series solution in the powers of x to the power minus n of the initial value problem is that. So we introduce a dummy index x dash is equal to x minus 1. So x become x dash plus 1. We need to find the power series solution around x is x minus 1 or x is equal to 1. Can say. So if x is equal to x dash plus 1, dy dx will be same dy dx dash, and also d2y dx2 will be same as d2y dx dash 2. So the equation which was given x d2y dx square plus dy dx plus 2y is equal to 0. So it will become x dash plus 1 d2y dx square plus dy dx dash plus 2y is equal to 0. X dash is variable and so is y. It can be replaced by x plus 1 d2y dx2 plus dy dx plus 2y is equal to 0. Now we can solve the power series solution. It will be n is equal to 0 to infinity cn x to the power n. We know what is dy dx and d2y dx2. N minus 1 into n and d2y dx2 cn n into n minus 1 x to the power n minus 2. So putting these all values in the equation, we get the relation, that is n is equal to 0 to infinity cn n square x to the power n minus 1 plus n is equal to 0 to infinity cn n minus 1 x to the power n minus 2 plus 2 into n is equal to 0 to infinity cn x to the power n is equal to 0. So here the limit starts from n is equal to 1 and it starts from n is equal to 2. Okay. Now n minus 1 is replaced by n. So it will be n plus 1 and that also will be n plus 1 whole square, and here it will be cn plus 2 n plus 1 into n plus 2 x to the power n plus 2 n is equal to 0 to infinity cn x to the power n. Square x to the power n plus n is equal to 0 to infinity cn plus 2 n plus 1 into n plus 2 x to the power n plus 2 into n is equal to 0 to infinity cn x to the power n. So equating the coefficient of x to the power n to the power 0, we get n's relation cn plus 2 is equal to minus 2cn plus n plus 1 whole square Cn plus 1, it is n plus 1 and n plus 2. So we need to write the equation. Sorry Payal, the call dropped due to the bad network connection. The part you have missed, it will be in the recorded version. Okay. C1 x minus 1 and so y1 is equal to 2 and y dash 1 is equal to 4. That has given us is C0 y1 is equal to 2, means here if we put x is equal to 1, every term will vanish, only C0 is there, so C0 is equal to 2, and y dash 1 only C1 will remain. C0 due to the differentiation, C0 is vanish already, and when we put x minus 1, this term will also vanish, so C1 is equal to 4. Now when we put n is equal to 0 in the recurrence relation, we get C2 is equal to minus 2 C0 1 minus 2 minus half of C1, which is minus 2 minus half into 4, which is minus 4. When put n is equal to 1, we get C3 n is equal to 1, we get C3 is equal to minus 2 C1, 2 into 3 minus 2 C2, 3, so it will be 4 by 3. So y is equal to 2 plus 4x minus 1 plus minus 4x minus 1 whole square plus 4 by 3 x minus 1 whole cube, and so on. Choose the appropriate answer. Consider the differential equation. So we need to write the differential equation: d square y dx square plus x plus 2 by x square minus 3x dy dx plus 1 by x square minus 3x into y is equal to 0. So x square minus 3, the term px, it is px and it is qx. For px and qx to be diverse, it should be 0. So x is equal to x minus 3 is equal to 0. So when x is equal to 0 and x is equal to 3, there to 3, they will be singular point. Again, when that thing will be regular singular point or irregular singular point. For regular singular point, x minus x naught px and x minus x naught whole square qx need to be finite. When x naught is equal to 0, let us put like this: x into x plus 2, x into x minus 3 px, it is x minus x naught px. So it became finite, because now we need to put x is equal to 0, so it doesn't diverge, and also x minus x naught whole square, here x naught is equal to 0, x plus 2, x into x minus 3 qx. So Here it will be become x into x plus 2. What happened? Plus 2 by x minus 3 qx. So at x is x not is equal to 0. If we put 0 in terms instead of x, it also gives us a finite value. So x not is equal to 0 is a regular point, and similarly we can see that when x not is equal to 3, again it is a singular regular singular point, x into x minus 3. So this vanish. So if we put x is equal to 3, like x, if we put x naught instead of x, it will give a finite result. Similarly, x minus 3 whole square, x plus 2, x into x minus 3, it also gives finite result. So it will be both regular singular point. And the last question is that it is like give the solution using Frobenius method. Sorry. So for Frobenius method, we need to consider y as Cn x to the power n plus r. So dy dx will be Cn n plus r x to the power n plus r minus 1, d2y dx2, that is start from n is equal to okay, it doesn't start from n is equal to infinity, because there is another coefficient r, x to the power n plus r minus 2. So plugging this term in the equation, x square d2y dx square plus 4x dy dx plus x square plus 2 to y is equal to 0, we'll get n is equal to 0 to infinity. I will write the whole part by multiplying x square into d2y dx2. So it will be Cn n plus r minus 1 into x to the power n plus r plus 4 into n plus r Cn x to the power n plus 4 r, and also here it will be 2 into Cn x to the power n plus r plus 2 into no, not 2, it will be Cn x to the power n plus r plus 2 is equal to 0. Now we need to replace n plus 2 as n. So then it will be Cn here n plus r plus 3 plus 2 x to the power n plus r. When we write all this part, then let me use another color. To this 2. When we simplify this, we get this part. Okay, and the fourth term. So it will be n is equal to from 2 to infinity. These are n is equal to 0 to infinity. So it is Cn minus 2 x to the power n plus r is equal to 0. Okay. Now we need to write all the terms from n is equal to 2 to infinity. So for n is equal to 0, this term will be C1 r into r plus 3 plus 2 x to the power r plus C1 r1 r plus 1 r plus 4 plus 2 x to the power r plus 1 plus n is equal to 2 to infinity, again whole term. So it can be written as total r into r plus 3 plus 2 x to the power r plus C1 r1 r plus 1 r plus 4 plus 2 x to the power r plus 1 plus n is equal to 2 to infinity Cn n plus r plus 3 plus 2 Cn minus 2 x to the power n plus r 0. So this part, okay, it is r, so this part needs to be 0, this part needs to be 0, assuming that C naught is equal to 0 and C1 not equal to 0. So if C naught is equal to 0, then r into r plus 3 plus 2 is equal to 0. So here r is equal to minus 2 minus 1. If C1 not equal to 0, then r plus 1 r plus 4 plus 2 needs to be 0. Here we get minus 3 and minus 2. And from the another part we will get Cn is equal to minus Cn minus 2. From the coefficient of x to the power n plus r, we get n plus r plus 3 plus 2. So if we choose C not equal to 0 and C1 is equal to 0, so r is equal to minus 1 minus 2. From this Cn becomes Cn minus 2, n minus 1, n plus 2 plus 2, and there is minus here. Cn becomes this. So C1 is equal to 0. C2 will become minus C naught 1 into 4 plus 2, which is minus 1 by 6. C4 will then become C2 minus 3 into 6 plus 2, which is 1 by 120. And for R is equal to minus 2, then Cn became minus Cn minus 2, n minus 2 into n plus 1 plus 2. So C2 become minus C naught 0 into 3 plus 2, which is minus half. C4 became minus C2 2 into 5 plus 2 is equal to 1 by 24. So we get different value of C2 and C4 when R is equal to minus 1 and R is equal to minus 2. We need to add both of these. So y is equal to 1 by x square when we consider C2 is equal to minus 1 by 6 and C4 is equal to 120. So it will become x minus x cube 6 plus x to the power 5 matter 5 by 120 dot 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 plus here it will be x square 1 minus x square by 2 plus x to the power 4 by 24 and all those things. Here it will be C1 and it will be C2. So this is the answer. Now coming to the problems of this. So here I is equal to contour interval cos square z minus z square z minus a whole cube dz. Okay, so we need to find the pole. Here pole is z minus a is equal to 0, z is equal to a, and this third order pole. While are you following? Hello? Hello? So for the third order pole, the residue is, for nth order pole, residue is 1 by n minus 1 factorial dz n minus 1 z minus a to the power n f of z, that is limit z tends to a. Here third order pole residue will be limit z tends to a 1 by 2 factorial d squared dz to z minus a whole cube z minus a whole cube cos square z minus z square. So it will become limit z tends to a 1 by 2 factorial d dz square to cos square z minus z square. So infinity 1 by 2 factorial to be d dz minus sine 2z minus 2z. Again limit z tends to a 1 by 2, it will be minus 2 cos 2z plus 2. So it will be minus cos 2a plus 1. So integration is 2 by I is the sum of all residue. So 2 by I into minus cos 2a plus 1. So answer is this. But I have checked that answer is given this cos 2a plus 1 into 2 pi I in the answer key. If it remains this, so whatever we calculate, it is for anti-clockwise direction. For clockwise direction it will be minus into minus, so minus minus plus. Like in this equation it is counterclockwise direction, so it will be 28 will be okay. The problem is I z dz sine h 2 pi z. So to know the pole we need to calculate this. Sine h 2 pi z is equal to 0. Sine hyperbolic function is 2 pi z minus e to the power minus 2 pi z by 2 is equal to 0. So we can 4 pi z, 2 is equal to 0, e to the power minus 2 pi z in the right hand side, then it will multiply it to 0. So e to the power 2 pi n I is equal to 0. So z is equal to n I by 2. So first is equal, and in the question it is given that radius is 3 by 4. Like radius should not be greater than 1. So for n is equal to 0, it will be 0. So n is equal to 1 plus minus 1, it will be minus I by 2. When z is equal, when n would be 2, z would be plus minus I. That's radius is greater than 3 by 4. So we will take only n is equal to 0 and n is equal to plus minus 1. So z value is 0 plus minus I by 2. So we need to like as z, so we need to calculate the residue at z is equal to 0. So there is another rule. They are all single pole, not third order or second order pole. So f of z is phi of z dash z, and phi of z is not equal to 0 but phi of z at a. So here it is. And phi dash phi a is equal to 0, then the residue became f of z is equal to a phi of a by phi dash a, which will become here 0. Now residue at z is equal to plus minus I by 2. At z is equal to I by 2, that is limit z tends to I by 2, is z minus I by 2 into z into sin h 2 pi z. And if you put z is equal to I by 2, अरे यार, if we put z is equal to I by 2, it will be 0 by 0 form. So we need to apply L's hospital rule. So it will become 2z minus I by 2 2 pi cos of h 2 pi z. And here when we put I by 2, we need to remember some condition like cos of h I x. When we put cos hyperbolic 2 pi z z is equal to I by 2, it will become pi I. So it is I cos, it is cos of x. So cos of h pi z pi I sorry, it will become cos pi. So putting all this value, we get I by 4 pi will be, again we need to put I by 2 z plus I by 2 into z sin h 2 pi z. It will be 0 by 0 form. So L Hospital's rule and some residue. So 2 pi I into 0 plus I 4 pi minus I by 4 pi. So it is 0. So the answer for this is 0. The next question, 29. Is dy by dx, dy dx xy plus xy square. It is common, like 1 plus y, and then separation of variables, it is y into 1 plus y and x dx. So it can be written like this, which will give this value dy is equal to x dx, and the integration will give us ln y 1 plus y is equal to x square by 2 plus ln c. We can write this, or it can be written as minus c, so that the calculation remains simple. So ln y 1 plus y into c will be x square by 2. So y 1 plus y into c will be x square by 2. When x is equal to root 2, y is equal to e 2 minus e. So 1 plus y will be 2, 2 minus e. Hello? So y 1 plus y is equal to e by 2. So e by 2 into c, x is e to the power 2 by 2. Okay, it is x. So it will become y by 1 plus y into c x square by 2. It is division. E to the power x square by 2 into c. So c is equal to half. C e to the power x square by 2. C is equal to half, when y is equal to e by 2 minus e, x is equal to root 2. So y 1 plus y is equal to half, when x to the power 0 to the power 0. So y 1 plus y is equal to half. So y is equal to 1. This is the equation B. Answer. j0 to infinity aj x to the power j dy dx is equal to aj j x to the power j minus 1 d2y dx2 is equal to aj j into j minus 1 x to the power j minus 2. So putting all this value in the equation, x square y dash dash plus y dash minus 4y0, we get j into j minus 1 aj x j minus 2 x square plus j to aj x j minus 2 minus 4 aj x j is equal to 0. So it is j into j minus 1 aj x j plus j aj x j minus 1 minus 4 aj x j is equal to 0. So first we write the keep j in the left hand side, x to the power j minus 1 is equal to 4 minus j into j minus 1 aj x to the power j. Now we replace j with j plus 1, so it will become aj plus 1 j plus 1 x to the power j 4 minus j into j plus 1. Stay in the corner. Into aj plus 1 xj plus 1. This is equation 1 and this is equation 2. So if we sum them, so it will become j plus 1 xj plus aj x j plus 1 x into j minus 1 is equal to 4 minus j into j minus 1 aj x to the power j plus 4 minus j plus 1 into j a j plus 1 x to the power j plus 1. So comparing the coefficient of aj, of x to the power j plus 1 aj plus 1 is equal to 4 minus j into j minus 1 aj. So it will become aj plus 1 4 minus j minus 1 j plus 1 aj. So this is the answer. This is the answer, I guess. J minus 1. Okay. Now for 46. V dot dr is equal to, by theorem we can write this divergence theorem, divergence of V dr. So curl of V is ijk del del x del del y del del z. Here it is y 3x 0. So only remaining term is 2k. So curl of v ds, it will be ds. So it will only be ds k dash k dot k is equal to 1, only k term, so 2 in ds, so it will be 2 into pi r square. R is equal to 1, so answer is 2 pi. Unit circle, so answer is 2 pi. So the question 47 is m is equal to 1 1 2 3 12 2 3 2 1 0 0 0 2 2 0 0 3 0 3 0 0 0 0 1. We need to follow the conventional way, that is 0. So equation become 1 minus lambda 1 1 2 3 12 2 minus lambda 3 2 1. This is 0 0 minus lambda 2 2. This is 0 0 3 minus lambda 3 0 0 0 0 1 minus lambda equal to 0. So we need to calculate 1 minus, we need to evaluate the determination with respect to 1 minus lambda, which is 1 minus lambda by 12 0 0, and it is 1 2 minus lambda 0 0. This is 1 3 minus lambda 3, and this is 2 2 2 minus lambda. Again this 1 minus lambda 1 minus lambda 2 minus lambda 3 2 0 minus 12 1 1 2, sorry, so it became 1 minus lambda 1 minus lambda 2 minus lambda square minus 6 minus 12 minus 6 equal to 0. So this 1 minus lambda lambda square minus 6, 2 minus lambda square minus 3 lambda minus 12 equal to 0, which will become minus lambda square plus 3 lambda plus 10 equal to 0. From that we get lambda plus 2 into lambda minus 5 is equal to 0. Here we get lambda is equal to 1. From here we get lambda is equal to plus minus root 6. From it get lambda minus 2, it is lambda is equal to 5. So 5 is the greatest eigenvalue. So that is for today, and good luck for your exam.